Hello, Year 10. Just a really quick one. That question that I gave you yesterday was really mean, and a lot of you have managed to have a go at it. I think some of you kind of weren't quite sure where the force came from, so just copied it from the mark scheme but could do the rest of it. So either you're just amazing at moments and can calculate it all in your head, or you didn't write your working down, or you got confused and didn't ask. Remember, I did give you this question like on purpose to see if anyone actually asked me for any help with it, but nobody did, which is kind of sad. That's what I'm here for, you know. I'm just going to go through it though, very quickly. You know this is an F equals Bill question, but straight away I'm going to start writing my stuff down. So let's see what we've got here. Small weight placed on insulating bar, blah blah blah. So you've got your diagram, you've got distance here. Wire X is 5 centimeters long. Okay, so the wire that is in this is 5 centimeters long. I'm just going to go straight ahead and write 0.05. Okay. Carries a current of 1.5 amps. 1.5 amps. That should be meters. Calculate the magnetic flux density equals, we don't know. Well, we need to figure out what force equals. Now, if you had just put your force as this, you would not get the correct answer, but you would only lose, I believe, 2 marks. So you'd get 4 out of 6. Okay, which is still really good considering this question is supposed to be aimed at grade 8 and above. So if you just put this in, which is not a force, this is not equal to force. Okay, it is a moment, and I give you a hint here. You need to use an equation to calculate a turning moment. Now, what you should have found is that the moment, I'm just going to put m, equals a force times by a distance from the pivot. Okay, so I've redrawn this diagram over here. The small weight causes a clockwise moment. Now clockwise is that way, okay, and it causes a moment of 4.8 times 10 to the minus 4 Newton meters. That's important because you need to make sure you convert everything to meters for this unit to make sense. Now, for this to be balanced, the anti-clockwise moment, as in the moment that goes that way, has to be equal. So the moments are the same. Now, if this is my moment, I use this equation here, 4.8 times 10 to the minus 4 Newton meters, which is my moment, equals a force, which we don't know, and actually we need to figure whatever that force is out so we can work out the question, times by a distance. Now, your turning moment is your distance from the pivot in meters. So here, this is what we're looking at, this distance there, 0.08 meters, remember, okay, because that's centimeters, I've just converted it. Your distance in the pivot times by your force. So this times by this should equal 4.8 times 10 to the minus 4. So, if I've got 0.08 times by f, I want f by itself, I've got to divide both sides. Yeah, divide both sides by 0.08 to that crosses off. And let's see what we get. 4.8 times 10 to the minus 4 divided by 0.08 equals, and I get 6 times 10 to the minus 3. Okay, so I get f equals 6 times 10 to the minus 3, or if you want to write that in non-standard form, 1, 2, 3, my decimal point there, decimal point 0.006 newtons. Right, we now have the force. 6 times 10 to the minus 3 newtons. So again, F equals Bill, which you know, and because you've done it 3 times already, B equals F divided by IL, which equals, the force is 6 times 10 to the minus 3 over 1.5 times by 0.05. Notice that I'm using a different length. Okay, I'm using the length of the wire that is inside this magnet here. Okay, this length doesn't mean anything anymore because the wire here is not inside the magnetic field. Only at X it says 5 centimeters. Okay, so let's put that into my calculator. Right, 6 times 10 to the minus 3 over 1.5 times by 0.05 equals, and I get an answer of, well, it comes out on my calculator of 2 over 25, and if I convert that to a decimal, 0.08, and the unit, Teslas. Okay, so where do you get your marks here? Well, first of all, state the unit, 1 mark. You get 1 for doing this. Okay, if you get this answer, you get 5. I believe it's out of 6. Yeah, you get 5 marks for getting this correct answer. Okay, so let's say that you didn't get the correct answer. Well, you get 1 mark for this equation here. This here will get you 1 mark. Okay, writing the equation, putting the numbers in, substituting to get this gets you another mark. So you got 1 from here, 1 from there. Okay, then you get this one, the rearrangement, putting the numbers in, and then getting the right answer. So all of these ticks are 1 mark, and that adds up to 6. So there you go.